Hello, everyone, and welcome. Thank you for joining us today for this live stream event. Before we begin, I would like to just review two items. Our code of conduct, please take a moment to read through this. We here at the Microsoft Reactor seek to provide a respectful environment for both our audience and our presenters. We encourage engagement in the chat, but we just ask that you're mindful of your commentary, remaining professional and on topic. This session is recorded. Obviously, we're streaming to YouTube right now, and it will be available for on-demand access following the session conclusion. If you've not been on a live stream before through YouTube, just note that you do need to have an account created to access the chat. So if you have not done that yet, now is a great time to set that up, so for future engagement. And if you're not able to ask your questions today while we're on the stream, and live, you can always find us on meetup.com. You can search for the Microsoft Reactor, find your local or closest location, and message one of the organizers there. We'll hopefully be able to find an answer for you. So, today's session is the first session of a three-part series focused on building and working with virtual networks in Azure. In today's episode, they'll be showing you how to build a network with Bicep. The Reactor is pleased to be joined by Gwyn and Liam, both cloud advocates here, and content contributors to the Reactor program. So let me pull up our speakers.
Hey, everyone.
Hello, Gwyn. Hello, Liam.
Hello. How's everybody doing?
Doing well, doing well. How are you doing today?
It's all good. All fantastic. And it's exciting to be here again. Second time this week.
Right,
your second stream this week?
Yes, it is. It's my second stream, Gwen. I did one on Tuesday. It's always on. So much material to do, and I love doing this. So much to talk about. Okay, so I guess we'll jump into it because we have got a jam-packed session today. Loads to go through. We've got a lovely hands-on demo and a wonderful slide deck to go through. So my screen is up. I will just share my screen. There we go. Share PowerPoint. Wonderful. So welcome everybody to another wonderful session. Today is the first of 3 this month. So myself and Gwen are going to be building a network or virtual network in Azure. So using VNet, we're going to be showing you all about the security groups, how everything runs, how to deploy it, all sorts of goodness. And today we're going to build one with Bicep. So quick agenda. Those of you who have been on the stream before know that I love to do an agenda with these sort of things. So we're going to talk about a little bit about us. Who is Gwen, or who am I? Who is Gwen? What do we do? Where do we come from? And what are we playing with? We're going to talk a little bit about the series. We're going to look at what a virtual network is, introduction to infrastructure as code, because those of you who know what Bicep is, it is infrastructure as code, and how you can start. And then we've got a hands-on project as well. So a little bit about us. Gwen.
First, hi everyone. I should preface this by saying that I'm still a little sick. So if I have like a lower voice than usual, or I have to like take breaks, it's because of that. But hi everyone, my name is Gwen. I see a bunch of messages coming in the chat. A lot of people who frequent the streams and the sessions. So hello to everyone. Please be sure to send your hellos and when you're checking in from in the chat. But yes, I'm Gwen, cloud advocate here at Microsoft, YouTuber, .NET engineer, developer, I'd say, and a big fan of serverless. And really happy to be here with my colleague Liam, talking about some networking, some Bicep for the month.
Amazing. It's great to have you on, Gwen. It's great to be able to collaborate with you on this as well. It's fantastic. I'm super excited for this month.
Absolutely.
And a little bit about myself. So my name is Liam Hampton. I am a Microsoft Regional Cloud Advocate, just like Gwen. Open source contributor. Prior to being an advocate, I was an engineer. I wrote a lot of Golang and a lot of Node.js at IBM. I'm a technical blogger, so I've done quite a few things online. Through that, I've become an IoT enthusiast, a public speaker, and of course, I am a world traveler. So it's fantastic to be here, and I am excited to jump into the series. So, as you all know, and those of you who are new, I do series goals and episode goals. So our series goals for this series is to understand how virtual networks are built and utilized. And then I want you all to have a go yourself and put learned lessons into practice. So I want you to go away and have fun with this yourself. knowledge. It's just great to share all this knowledge. I really want to see what you come up with. And then secondly, today's episode goals, there are two. We want you to understand how to build a virtual network with Bicep using infrastructure as code. And we want you to understand how to automate, or how automation can help you speed up development in teams, because ultimately this is where it's most prominently used. The everyday developer doesn't usually do this. It's more of a widespread team scenario. So that's what we want you to take away today. So today's episode, obviously building a virtual network. We have got another one next week. So this is every Thursday that we're running. So the 7th, 14th, 21st of April. Next week, we're going to be working within your virtual network, and we're going to have a little hands-on showing you how to SSH into a virtual machine and so on. And then episode 3, of course, probably the most fundamental one is securing your virtual network, because it's brilliant having a network, but how do you secure it? How do you tie things down? Second to that, we have also got a Microsoft Cloud Skills Challenge for you to take away. So we really want you to have a hands-on experience. We want you to go through some Learn modules and really put some pieces of the puzzle together yourself. So like I said, this is our one today. Let's jump into it. Of course, I forgot this slide. You can do this too. Of course, I always forget this one. You can do it too. And if you're a student, then of course you can do aka.ms/A4S. And if you are professional, you can use https azure.microsoft.com/free. And of course, being Azure Virtual Networks, they are free to use. The only cost associated is the resources within. And that again is tied to pricing tiers and SKUs. So what is a virtual network? So I'm going to run you through the basics of what a virtual network is, and then the basics of infrastructure as code. And then Gwen is going to take it away with a hands-on for us. So essentially, a VNet is a private network in the cloud. And that is all it really is. It's everything that you can do in a data center, but online. Why would you use one? Is a really big question. Because if you say, well, if I say you can do it all in a data center, why use a virtual one? Well, first you need to understand cloud types. And there's 3. And we're going to go through them quickly. First one is a public cloud. And that's third-party providers like Azure, AWS, GCP. And I have just lost my screen. Let me just plug my laptop in. Sorry, 1 second.
No worries. We're going to drop all the links that Liam has in the slides and a little bit in the chat. But yeah, do make sure that you take advantage of the free tiers. And if you're a student, make sure you take advantage of I guess it's not a promotion really, but the credits that you get as a student in Azure. And yeah, lovely to see everyone checking in the chat. Quite a popular topic, it looks like.
Indeed. So I am back.
You're back?
Sorry about that, everybody.
No
yes, I forgot to plug my laptop in. I get like a power drain. Everything's like daisy chained on my desk.
No worries.
So sorry. Third-party providers is things like, or providers like Azure, AWS, GCP, IBM Cloud, DigitalOcean, all these wonderful public cloud providers. People use them because they can scale quickly. So when you have peak demand on your applications, you can scale up, scale down. So horizontal and vertical scaling. And of course, you have the shared responsibility model. And what I mean by that is you as a developer may say, hey, I want a virtual machine with this operating system. So you've got an operating system. Your responsibility is to keep that up to date so that vulnerabilities don't creep in. Cloud provider's responsibility is to make sure that the hardware is staying up and running, that the virtual machine is running on. So that's the shared responsibility model. And of course, that's very quick. There is so much more to it than that, but that's the general gist. Secondly, we've got private cloud. And private cloud is deemed, well, it's basically on-premise. And that's what I mean by on-prem. Very, very secure. It's essentially just someone's data center, your data center. You have access and nobody else. Very, very limited. For example, a government agency would have a private on-premise cloud. You probably wouldn't use, third-party providers for that unless it's sort of deemed responsible enough to do so. And thirdly, we have got hybrid cloud. Now, hybrid cloud is what it says on the tin. It's a mixture of both. It's a hybrid. So you have public cloud and private in one, and there's a shared security with this one. And essentially with hybrid cloud, if you think about it as maybe a government agency, like I just said, if you have a front-end website, which is just low security, doesn't really care, it's just the face of who you are, you can probably put that in the public cloud. But if you have got data sensitive or sensitive data on the back-end virtual machines and whatnot, you'd probably have that in a private cloud because you want to keep that down under lock and key. So that's where hybrid cloud solution really fits. Now, today we're going to be looking at public and hybrid. And that is because you don't necessarily use virtual networks with private. So if you want to be communicating within Azure, there's a number of ways you can do that. First of all, you would have resources. So you can deploy resources into and through a virtual network. Things like virtual machines, app services, Kubernetes, databases, and all those sorts of lovely sort of resources you want in the cloud, you can deploy them into a virtual network. Secondly, you've got virtual network service endpoints, or rather APIs essentially. So storage accounts and SQL databases of where you have a direct connection to that service. So you're not just deploying it and hitting a network, you're deploying it and hitting the service and all the resource itself. That's done through a service endpoint. And then thirdly, you've got VNet peering. And VNet peering is when you've got multiple VNets or virtual networks in the cloud and you want to talk to each other. Now, the fantastic bit about this is you can have different virtual networks in different regions around the globe, and they can talk to each other through a secure route. So that's how you can communicate within Azure, and that's predominantly public cloud. However, if you want to communicate outside of Azure, i.e. in a hybrid scenario, there's a number of ways you can do that too. You've got point-to-site, VPN. So VPN is an encrypted tunnel for network traffic, so it's secure. But a point-to-site one is a single computer, i.e. your desktop, my desktop, talking to a virtual network. Now that's done, again, through the VPN, through an encrypted tunnel, and that's probably used through maybe an application like Putty, for example. That's a really good way, or SSH, if you're familiar with that. So a single computer to a virtual network. Secondly, we have site-to-site VPN. Now, site-to-site VPN is, again, a bigger version of point-to-site. So you've got on-premise networks. So you might have a local virtual network or a local network talking to a virtual network in the cloud. Again, done through a VPN, and this is through an encrypted tunnel. And then finally, we have Azure Express Route. Now, this is a service provided by Azure, and we have got partners which will allow you to use a third-party provider to connect to Azure from your site. So rather doing it site-to-site and through your own way, you can use a third-party provider. No traffic goes over the internet with this, like I've got on this slide. It is very, very secure. This is probably the most secure way out of all of them if you want to get a connection to the cloud from your premise, your on-premise site. So we look back to why you'd want to use a VNet. Well, there's three main reasons, and this is where the power of the cloud comes in. Already kind of mentioned one, and one of them is scale. You can scale in, scale out, scale up, scale down. You can scale with the cloud. Okay, it allows you to do that very quickly. Imagine you have a website and you have peak traffic on a Friday afternoon. You can scale up instantaneously with the cloud, but if you had your own data center and your own servers, you'd have to get an engineer to come in and sort that server out and spin it up and do the configuration, by which time it's midnight and the peak demand has dropped again, so it's useless. So scaling is a really, really big one for this. Secondly, we've got high availability. Now, high availability is essentially having multiple servers acting as one. So you have failover. So there's little downtime. So if something does go wrong, you'll never notice because it'll always be available with the second server, like the failover server. And thirdly, we've got isolation. Now, a virtual network is essentially a little box in the cloud, which is isolated from everything else around you or everything else around it. And it allows you to have direct access and only direct access with isolation. Think about multi-tenancy, or rather than not multi-tenancy. If you are using the cloud, you can have dedicated hosts. And that means that you won't have multi-tenancy. And multi-tenancy is when you've got multiple users using the same physical hardware, completely separated from each other. But you wouldn't have that. You'd have a dedicated host where it's just you. You have that server to yourself and you only. So again, you choose. It's up to you. But it's at the power of the cloud. Therefore, you're utilizing it. So what does it all look like? And here's a quick diagram which we'll run through. So we've got the internet, which is coming into Azure. So we've got some traffic coming into Azure. In Azure, we have got a virtual network. And inside the virtual network, we have a public subnet and a private subnet. Inside a public subnet, you might see something like a front-end server, number 1 and number 2. And in a private subnet, you might see back-end server, number 1 and number 2. And of course, a database. You never want to put a database in a public subnet because that's public-facing. Always want to keep that safe and secure. Same with back-end servers. All your encrypted traffic would probably go between these two. But you want your users to see the front end. So it'll be in the public subnet. But hang on a minute, Liam, you have got 2 front-end servers. How do you know which one to use? Well, the simple question here is the load balancer. And a load balancer would determine how much traffic is sent to either virtual machine or either server. And this is a very quick overview of what a virtual network kind of looks like. And this is pretty much the standard, unless you've got some other cool things going on with serverless functions and all these kind of endpoints happening all at once. This is a very sort of basic overview. And it's good because it illustrates a point quite well of saying this is public facing, the user can see this. This is not public facing, this is very private. So we want to keep this under wraps and only the public subnet can talk to it. So when it comes to filtering and routing traffic through your virtual network, there's a number of ways you can do that. The first one is with network security groups. Now, security groups essentially block or allow traffic. And by default, I believe they block. We're going to go into much more depth on this in episode number 3. But it's essentially a really good way of filtering your traffic at a very granular level inside the network. Secondly, we got virtual appliances, and these essentially act as virtual machines that perform network functions, like a firewall or like WAN optimization, for example. So it's not necessarily having a rule, it's actually having a virtual machine. It's a little bit more costly, but it serves a little bit better. And then to route your traffic, you can have custom routes. So you can say, any of the traffic coming from this region directly go to that virtual machine or that server only. And this could be to do with governance. This could be to do with compliance, anything like that. But you can have routing tables, and route tables will help organize that for you. You can have custom route tables as well. And finally, Border Gateway Protocol and shorthand BGP. And this is this is quite an in-depth topic and quite advanced. So we're not going to go into too much detail. I might touch on it later in the 3rd episode later in the month. But essentially, this is knowing who's next door in your network. So BGP is all about knowing the network and what's the fastest way to get in and out of that network with the traffic. And you'd use this if you're going from an on-premise to an Azure VPN gateway, or if you're utilizing Express Route. Really, really handy to understand them. But again, it's very, very advanced. So I'm not going to touch too much on that one. So that's a whistle-stop tour of virtual networks, what they are and what we're going to be playing with. Now, up next, I'm going to do an introduction to infrastructure as code and kind of what it is, what we use it for, and some challenges. So what is infrastructure as code? It's automation. That's what it is. It is automating the infrastructure provisioning in the cloud for us. Now, it's usually written in the code stage of DevOps. If you haven't already seen this, this is the unofficial DevOps lifecycle logo. Essentially, you have the 8 stages here, but teams usually write it in the coding stage. And it's then used in the deploy and operate stage later on in the process with the team. And the kind of things that it deploys is really cool. It can deploy anything from web servers to databases to load balancers, and of course, networks, and so on. And it's really good because this ties in nicely with our episode today and what we're doing. So how does it do that? Well, it uses decorative and imperative coding. I'm going to circle back to these a little bit later on, but that's essentially what it is. Now, before we get into that, if we think about how coding really works and infrastructure really works with the cloud, you write your source code. Your source code is then using an interpreter to turn it into essentially machine code to be able to run the application and deploy it. And that is when you have your deployed application in the cloud. Now, if we look at infrastructure as code, we're going to be writing some IAC code. So Bicep or ARM or CloudFormation or something along those lines, right? That then calls a service API. Now, the service API is what's in the cloud and essentially allows us to deploy applications. So infrastructure as code hits the service API and is then deploying your application for you. Why do we use it? Well, it's essentially so we can reuse code. And I've got a really good diagram coming up to show you why. Imagine we've got a development environment and we want to replicate that, but we don't want to send an engineer to do this 3, 4, 5 times, right? We can just use one test file or one infrastructure as code file to create the same development environment with pre-prod or a test environment, and then ultimately with production as well. So how does it help with deployments? Now, you've just seen this diagram, but ignore the fact that it says deployment and production. Let's scribble those out and call it version 1 and 2. Some of you may see where I'm going with this one. Blue-green deployments, right? So blue-green deployment is where you have version 1 and 2 both in production, and you slowly phase one out and bring the other one in. So let's imagine that version 1 has got 90% of our traffic and version 2 has got 10%. Well, we would then slowly transition version 2 to be the dominant version here and slowly phase out version 1. But what also makes it really cool is the fact that we can test in production. So if something's going wrong with version 2, we can just pull it straight out again. But we've essentially used one file to create two environments that are identical, that allow us to play and test. Okay, that's an amazing power we have because it saves money and it saves time, especially within the agile methodologies of quick turnarounds and the DevOps lifecycle process itself. So what are some of the challenges that we face with infrastructure as code? Because it's not all roses, I promise. As much as I like to say all the good things, it does have some drawbacks. Config drift is a big one. Now, what I mean by this is a laser pointer on the screen, right? This represents my little hand tool here. At the very bottom, if I was to move it just ever so slightly to one side, at the very beginning, it doesn't seem like there's a very big change at all. But by the time, the further away it goes, and by the time you reach the end, that change is quite big. Now imagine doing that in small configuration files over time. That suddenly gets bigger and bigger and bigger. So then you kind of end up with something so wildly different to what you started with that it's too different to really replicate. So it's called config drift. That's what it's called. Secondly, we have duplication errors. So if you can imagine you're deploying the same file over and over again, if you don't clean up those resources, more often than not, it's smart enough to know you've got duplicate resources, but sometimes some things might slip through the net. So you can end up with duplication errors. And that's what you don't want to be faced, because then you have to figure out what you have to delete. So that's not a good one either. Thirdly, it's a skill. So writing code is a skill in itself. Having to learn infrastructure as code is like another paradigm and another way of thinking. So that's a skill to have with any developer. And then finally, you're handing over a lot of control. Now, if you think about what you've written, your infrastructure is going to be deployed, but it's being deployed by a third party. Let's take Terraform. Fantastic, wonderful tool. But you're relying on Terraform to deliver your infrastructure time after time. You're putting all the responsibility on them. You're kind of handing it over to them. You write the code, you give it to them, they say yes, it's deployed. What if they have any downtime? Well, then you're a little bit stuck. So you hand over quite a lot of control to third-party vendors in this sense. So how can you start? And this is where I'm going to loop back to declarative and imperative coding, because you need to understand this first. Imperative coding is kind of organized code of how you and I might think as humans. Very logical, i.e. task 1 happens, then task 2 happens, and task 3, task 4, 5, and so on. Very methodical is a way to put it. So that's imperative coding. And a really good example of that is Chef. I've used Chef a number of times and I love it. It's good, but I do prefer declarative coding. Declarative is the most popular version, or the most popular way of writing infrastructure as code. And this is where you define the end goal of the system and any of its attributes. And then you go off and say, hey, go and deploy this for me. Go figure it out. And what I mean by that is you'd say A is equal to ABC, like we've got on the slide, and B is XYZ. But better to that, you can say, I want a virtual machine. And virtual machine is going to have a name. So you give it a name, you give it a size, you give it its operating system, you give it its memory. Anything like that is declarative coding. You're saying A equals B. And some great examples of that is Terraform, Bicep. Ansible is a questionable one. There are some imperative coding parts in there, but it's deemed more declarative than not. And of course, you have ones like CloudFormation, Puppet, SaltStack, so many good things going on. And there's brilliant examples there. We are going to be focusing on one of them today, and it's Bicep. Bicep is fantastic. So what is it? It's a declarative language, as we've just established. Second to that, it is quicker than ARM templating, and there's a reason for that. It's a domain-specific language. Now, what happened was ARM templating is essentially JSON. It gets messy, it gets a little bit confusing at times. People kind of like it's a bit of an arduous task to write an ARM template, which is why in Azure, we kind of give them out to you, right? If you were to go and deploy something, you could download an ARM template because you wouldn't want to have to write it every time. So Microsoft thought, hey, let's create a language. Makes it easier. So you learn a new language and it converts it. It's a wrapper around ARM. Essentially this, right? You have a Bicep, you write your Bicep template. You build it, it converts it to a JSON file, ends up as an ARM template. You can then deploy that into Azure. So the project, we're going to be playing with this today. So we're going to show you how to do that. Prerequisites is the Azure CLI, so AZ CLI. You've got the AZ Bicep extension, which you should install as well, and in VS Code to be able to help you write this and sort of navigate the syntax, should we say, Bicep VS Code extension. And of course, the obvious, you need an Azure account. But like I said at the beginning, you can get that and you can set it all up as well for free. So step number one, we're going to write some Bicep code, or rather Gwen's going to write some Bicep code. And this Bicep code is going to have virtual networks. It's going to have some VMs or some virtual machines, network interface cards, public subnet, a private subnet, and a network or 2 network security groups. Kind of touched on all of that a little bit, but stay with us. This is going to make a lot more sense in the next slide. Step number 2, we're going to deploy it. And it's going to look a little something like this. So on the left-hand side, we've got virtual machine 2 with a subnet and a network security group and a network interface card. And on the right-hand side, we've got virtual machine 1. And again, network interface card. We have a security group and it's in a subnet. But the wonderful thing about this one is there's a slight difference. Virtual machine 1 is in a public subnet. And you can tell that because it's got a public IP. Now, what that means is that the external internet traffic can see it. It can call that IP address, and usually that'll be an IP that is translated onto a load balancer. But we're not going to do that yet. We're just going to focus on this in this episode today, and we'll be touching on that in another one. So Gwen, it is now over to you to show the lovely people how it's done.
Awesome. Good timing, good timing. There were some great questions in here. I think some of these we might be able to tackle in like following sessions, because next session we're talking about how we can actually work with this infrastructure, and then we're going to talk about securing it and a couple of other things in a third session. So just for like a timing kind of thing, we're going to try to not address absolutely everything today. Let me bring up my screen. Give me just 1 second. I have here we go. Completely blank file. That means we have endless possibilities. Also, thank you to everyone who's been adding questions and such to the chat. It is now Liam's job to be answering all of those. So anyway, we'll have Rebecca, if you could please drop the GitHub link. That'll have where I'll actually we'll push all this code to. We have links there, same links that we've been sharing throughout the session in that repo. So it's all sort of in one space for y'all. So y'all can take the time to pay attention today. But anyway, yes, Liam did a great job at introing not only all the theory, but like this concept of Bicep and sort of what we're going to be building today. So with Bicep, you obviously have a full file that's .bicep. Now, these files are your infrastructure as code templates and such can get pretty big. But today we're just going to have one. You can split things into modules and have it a lot more broken up. But since what we're working with is relatively small, let's say it's more of like a development level kind of thing, we don't need to do that for today. But I'm going to copy over this first line and we're going to sort of break it down. Because a lot of these things are just, we'll have multiple parameters, but we don't need to look at every single one of them, but I can describe sort of the different concepts that come into Bicep with just one example, right? So let's take a look at the slide. Actually, is this text size good? Chat, let me know if we want to do one bigger, maybe like that. I think that's good, right? Also, I don't usually use a light theme. I only change it for live streams. So your audio is coming in through weird. Is my audio all right? People, let me know. Before I continue, what are we thinking? Liam, can you hear me fine? Or chat, can you let me know?
You sound okay now. You were coming through a little bit weird.
All right.
You sound okay now. It was a little bit crackly, but go forward.
How about now? Audio seems choppy. Audio's better now. All right, cool. I think it might be StreamYard does this thing where it automates the audio. So if you're too far, it'll like it's like a compressor. No, it's not. It's like a gate thing. Anyway. All right, we're good now? Good now. Cool. Alrighty, so let's talk first about parameters. So with Bicep, or if you're familiar with programming or scripting, you might be familiar with this concept of parameters. It's a way of us bringing data or values into your file, to your Bicep file, right? And this can be via command line, via a parameters file, or a default value. So here we have this keyword, param, which says, all right, Bicep, I want to create a parameter now, okay? And this is the name. Pretty straightforward. This parameter is going to hold the value for our VM1, right? Then we have the type of our parameter, which is a string. And then we have an equal sign and a value here, which means that this is going to
Gwen,
be...
your audio's gone a little bit funny again.
Again, goodness. Give me a second. Let me take a look here. We'll go here. It's so odd. Audio is breaking up again. Let me see here.
It sounds like there's some kind of interference with your microphone, like a loose connection.
Could be. But now it's clear. All right, let's do this.
Yeah, it's clear now.
Loose wire. Maybe loose wire. Hold on, everyone. Should I try leaving, coming back again? Let's do that.
Yeah, you can do. You can leave and come back. Is there any questions in the chat? So I should do that. I'll see if there's any questions that I can address quickly.
Yeah. Be right back.
Okay, so let me just scroll through the chat, everybody. Let me just see what's going on. Okay, so Cool. So not so much experience in networking, have set up some cloud VPN and architecture VPCs. Yes, I forgot to mention actually, as I was going through, so you'll notice I say VNet quite a lot. Now in Azure, we call it a VNet. However, this is pretty standard across sort of all cloud architectures or cloud providers, should we say. They all call them something a little bit different. So maybe like in AWS, it's VPC. I'm not quite sure what it is in Google Cloud, but certainly over in Azure, we use VNet for virtual networks. So it's good to see that people are here. It's great. The chat is on fire. Fantastic. What's up, CyberQ? Hey, so she said, so we got some wonderful. We have people from previous streams. I'm seeing you. Fantastic. Okay, so what are the questions? So Gwen should be back any moment. Yeah, do something similar in Terraform. So Terraform, I actually did a stream around infrastructure as code using Terraform and Azure App Services. If anyone's interested, that was in like a previous DevOps series that I ran. So this is kind of similar. You may have seen some of these slides before if you're joining from a few weeks ago. What else do we have? Do you store IAC with the associated project repo or on its own? Great question, George Fentress. So yeah, that's a good question actually. And I know Gwen may have kind of already answered that one, but certainly I keep them. Hey Gwen, it's nice to see you back. Just answering this question around IAC being associated with project repo or on its own. And my personal experience, I leave them out of the project repositories. I have them in their own repository for their own safekeeping. Okay, how's the audio doing, Gwen?
I don't know. How is it? Still choppy? Is it good? What does it sound
better.
like?
That sounds good.
Let's give it a second. All right, cool. Well, let me bring up my screen again because I'm going to have to...
Awesome. I'll let you take
Do we
over.
have more questions?
I was only going sort of halfway through the chat.
Hopefully it doesn't go weird once I share my screen again. How are we doing now? Still sounds good?
Yeah, that's all good, Gwen. You're good to go.
All right, where were we? All right, I'm kind of like a paranoid now, but we'll take it as it goes. All right. We're talking about parameters. We have the value type, and then we have the name. Default values. So you can see we have between single quotes that the like default value that we're providing the parameters here. So like I mentioned, you can give the parameter the value through the command line, through a parameters file.
Gwen, it looks like your screen share is causing this audio issue.
It's back?
Yeah.
Hold on a second. All right, how am I now?
So I can hear you now. Like it only happens when you start sharing your screen. That's very odd. Interesting.
Do you want to bring up? Hold on a second.
I don't have any of this open, Gwen. 1 second. I was not expecting this one. Let me just see.
good without screen. Interesting. Do you want to open up the Bicep file and I would just talk through it with your screen? I think that would be...
Sure, let me just grab it from GitHub. Bear with one moment, everybody.
Suggestion: don't lean close to the mic. No, I think it's the share, the screen share. That's interesting. I typically do. Let me see here. Oh, here we go. Don't worry, Ron. We'll figure this out. This is the beauty of live streams. These issues happen all the time.
This is good, isn't it?
Let me take a look here. We have the GitHub link here. I'll share it once more. One second.
I'm just opening it up now, everyone.
Okay.
Okay, so we got the main Bicep file. Cool. So this one is quite a chunky one, actually. So let me just share my screen again. So I was not prepared for that to happen. I apologize, everyone.
I wonder if it's Edge. This is interesting. I wonder if it's the browser I'm using.
Then I'll be interested to find out, that's for sure. We can do some more testing on this.
Should have used Chrome.
Yeah, I'm in Chrome. Alrighty, well, I've got the Bicep file up. So Rebecca, please can you throw my screen up at the top? Cool. So I'm going to let you run through it, Gwen. I'll go as slowly as you talk.
Yeah, let's do it. Do we need to zoom in a little? People, what do you think? I'll try to go through this.
Let's zoom in anyway.
I'll try to go through this as quick as we can. But like I was mentioning at the top, usually with Bicep files, we have like parameters. Parameters allow us to bring in values. You can see the ones that have values within single quotes. Those are default values. But there's sort of like an override. What do we call this? Like a precedence? I think that's what it's called. So if we provide a value via a parameters file, that is going to override a default value. If we provide a value via a command line, that's going to override the parameter file and default value. So you keep that in mind. But if no value is provided, the parameter is just going to grab the one that is in the single quotes, aka the default value. Okay. So we have that available for our VM1, and then you can see that above each parameter we have an @description. These are called decorators, and these allow us to comment and just provide descriptions of what each parameter is actually doing. And I have this for every single parameter, and pretty much anything that you can sort of, comment your code with, we try to do that. So anyway, that's in there too, right? Now, so our first two ones, we have the names for the VMs, and then we have the admin username, which I just set to made by GPS. And then again, we have this other parameter that's called Authentication Type. But we see here we have something a little different. We have an @allowed and what looks to be like an array. So this is another type of descriptor. And this essentially tells the parameter that's directly beneath it that, hey, this parameter can only have values that are inside of this array that are set to the @allowed. And in this case, it's SSH public key and password. If you're familiar with working with virtual machines, especially like Linux ones, ideally you would use an SSH public key, but we have both options there just in case for whatever reason. All right. Then we have a couple more parameters. We've got the admin password key. We've got and so the next one that sort of is a little different is this parameter DNS label prefix VM1. And you can see that the value is being we're not providing a, what do we call it, literal value, because we're calculating it via a function. So you can see we have actually two functions here. We have toLower, and then we have unique string. In Bicep, the unique string function allows us to create a unique string given whatever values we're providing. And in this case, we're providing the resource group ID. So we're going to create a unique string with that resource group ID. Then we're going to prefix that with VM1 dash that value that's generated there and make sure everything's in lowercase. So you see it says toLower, right? So this is essentially going to provide us somewhat of a random value for our DNS label prefix for our virtual machine 1. And we don't have one for VM2 because remember we're saying we're just going to keep that private, so we're just going to use a private IP for that one. Fantastic. So the next, all these other ones are just things that we need for the virtual machines. A couple other parameters here. I'm trying to be aware of the time we have here. Okay, cool. Next, we have variables. Again, if you're familiar with programming, you might be familiar with variables. So variables are similar to parameters, except they're just meant to be inside your Bicep file, and you can't add values, assign values to them from outside of the file. So you can't provide them via command line, parameters file, anything like that. But you do provide your values for them in here as well. So you see we have public IP address for the VM1, network interface names for VM1, VM2, OS type that we want to use, subnet 1 prefixes, subnet 2 prefixes, all these beautiful networking things. And then we have this Linux configuration as well, which is where we're going to store our key information. You see we have a path and the key data. So you see this key data value, we're providing a parameter that's admin password key. So remember we declare that parameter up in the top where we're declaring parameters. So this is an example of how we use parameters or values that come in from outside of the file or provided a default file value into the actual file itself. Alrighty, so next, the file is actually kind of like, I wouldn't say all over the place, but like Liam said, when we work with Bicep, we have the concept of declarative syntax where it's like, it doesn't really matter. It goes step 1, step 2, step 3. It just, all you have to do is tell the file, like, this is what I want, go create it for me. And as long as Bicep has everything it needs, it can go and create it for you. So this isn't necessarily like an order that you have to do these in. So the first thing we have is we have a NIC1. Let's just like scroll through all of them, just see we have what NIC1. I don't think I put them in any order. Network security group 1. We've also got then we got NIC2 in there, and we'll keep going down. Network security group 2. So it looks like I did define them somehow, and then the VNets down there. I'm pretty sure the subnets, we've got 2 subnets. We've got 2 subnet 1 and subnet 2 under there. And then we probably have the 1 public IP address in there as well. And then we have the virtual machines towards
Now's probably a good time to just outline IPv4 for this. So obviously some of the network savvy folk knowing about IPv6, that's not really integrated with this as of yet, because we don't need that. This is just purely IPv4. And the same thing at the top with the variables. You may have noticed they're 10 dot variables, so that internal network traffic. That's all done through CIDR blocks. But again, that's like another advanced topic. So just to be aware of that one. So we haven't just thrown any values in for that.
Yeah, Sam brings up an interesting question here. Are the IP addresses binding to specific servers or network equipment in the variables? We can actually take a look at that. So we scroll back up to the top. We could start at like a nice NIC1. Where's NIC1? Yeah, here we go. So we can see here which way we're allocated. So obviously if we set the top, we'll have the name, we'll have the location, which is just set to the resource group location. Then we have properties specific to this type of resource. So with Bicep, how do we tell it what we're actually working with? Well, we have resource, which is keyword, like we're creating a resource, then the name of the resource, which is NIC1. And then we have this Microsoft.network/network interfaces, and then the version, right? So that is what's telling it what I want to create. So we're telling Bicep, hey, I want to create a network interface card or NIC resource. So then we got properties. These properties are specific to the resource. IP configuration. We've got the name, we've got the properties, and then obviously a NIC has to be associated with the subnet, so we've got a subnet there. And then here you notice that even though my subnet hasn't been declared, well, not necessarily declared, but we haven't written it out yet, it knows that it's there already, so it doesn't matter if it's above or below, right? So that's important to keep in mind. Then we have private IP allocation method. We're setting it to dynamic. Someone's asking if we could blow up the screen more. It's a little hard to see the code. Can we zoom in just once more?
Yeah,
maybe?
of course.
There we go. So with IP addresses, and Liam, you might be able to speak a little bit more to this, we have this concept of static and dynamic. And depending on your case scenario, you'll have to go with one. And I know IP addresses also have SKUs. I think in Azure we have basic and standard. I think those are the proper naming.
Yeah.
So all these things, like when you start building all your networks, they're going to have to be highly specific to what your needs are. But for this case, we're just going to keep a dynamic one. And then we're telling the NIC that you are associated with this public IP or this address in general. And we're providing the ID of that as well. If we scroll down a little bit more, we've got the network security group that we're associating this network interface card with. Fantastic. Mark says perfect. That size is perfect. Awesome. All right. So now you can start to see, like with Bicep, we have this sort of similar format. Resource keyword, the name of the resource, and then what resource it actually is. This is still in Microsoft.network, but this is now network security group instead of network interfaces, right? Again, we got name, location, and properties that are specific to the resource. And in this case, since this is a network security group, we have to define rules. Now, if we had more rules, which you typically do have, you could abstract this to another file and then in Bicep you have this concept of modules, where modules are essentially a group of resources that work together. And then instead of having it in your main.bicep, you'd have a different module. And then here you would tell, hey, main.bicep, go grab this network security group that's in a different module. And then you could have a parameters file for your rules themselves if it's really long, because you don't want to have it all in one file. But we try to keep it as simple as possible, and we just created one for SSH. Allowing inbound. So you would declare your rules there or in a different file, but that is part of specific properties for this type of resource. So we've got one network security group. I think we have, what's coming up after this?
Yeah, we got a network interface card as well. So NIC2, so we've kind of already been through the first one.
Yeah, the different one here is it doesn't have a public IP address. So that's the only really difference there.
And that ties in with the public-private subnets, right? And again, very much with the dynamic and static IP addressing and how this all kind of fits together is like a really big puzzle. And it's really cool when you get down to nitty-gritty parts, just like this. But yeah, we'll touch on that in later episodes.
Yeah, absolutely. If we scroll down, we've got this NIC2 covered, network security group 2, essentially the same thing as well. And then we got our VNet, which is probably one of the smallest resources here. But again, we got file the same one. Resource keyword, name of the resource, and then the type. And then we have name, location, properties, address space, address prefix. I think these are using parameters, right? Because we've already sort of declared them. So you can see how, your goal is to create parameters and later on create modules that are sort of self-explanatory. And they make your infrastructure as code files reusable, which is the goal, right? If you had to like hard code values straight into the where you're declaring your resource, it's going to be hard to maintain, also hard to share. So keep that in mind. So we scroll down, we got a subnet 1, and then again, we're utilizing a bunch of parameters in here. Look, the parent, the name, properties, all of these seem to be parameters, except for the private endpoint network policies, which we're just hard coding enabled in there. But if we needed to, we could provide those as parameters as well. Subnet 2 is the same. And then we've got our public IP address. This is going to be associated with our public subnet and then our VM that will have access to public internet. And we can see that, here we go, SKUs. I knew we had SKUs. Looks like our public IP address SKU is set to basic. I think basic is that by default all traffic is allowed, right? And then your standard one is all traffic is not allowed by default, something like that. Yep. You can see we have dynamic IPv4, like Liam mentioned before, idle timeout in minutes. We've got that all set up there too. And then we see here we have a DNS label, which we talked about towards the top that was calculated, or I guess comes together with the function of the random value. We've got that assigned here too. So that's our public IP. Scroll a little bit down more. We've got our first VM, name, location, hardware. Hold on a second. Still recovering from 1 second.
It's all good.
Oh, God.
You okay?
Scratchy throat.
I feel you. So essentially, this is virtual machine 1, right? So we can see where we're going with like the declarative language, can't we? So you can pretty much say name is VM1, right? And that's like a label attribute that was defined prior to this. So it's very much kind of like JSON key value pairs. And that's pretty much what it is, but it's a wrapper around ARM templating. So it kind of all just jumps into place. Very much a puzzle that you put together. It's very, very sort of fussy. Very fussy when it comes to getting like the right values and attributes for deployment. But with a little bit of tinkering, you can get there. And that's all part of these plugins that help you get there.
All right, I think I'm good. I think so.
Awesome.
Up until the very end. So many issues. The stream almost didn't happen, but anyway. Yeah, so essentially, you can think of when you're creating a virtual machine in the portal and you click all these things, right? You click on what size, what kind of disk, what image are you using, all those kinds of things. You have to provide all that in your Bicep file. But we've essentially declared all of these things in parameters, so they're outlined here as well. We scroll down a little. We associate. We're associating the network interface here. NIC1, you see it's here as well. And if we go to our OS profile, we've got the name, the username, which we're going to use to SSH into it. And here's a tip for y'all. So first, I was trying to figure this out, and it wouldn't accept my SSH, like my public key, when I was providing it as parameter via the command line. And it kept giving me an error. So then after like a bunch of Googling, like hours, I found that any function. So we see in Linux configuration, we have that any function right before the authentication type. Essentially, this allows us to bypass any formatting issues that we're getting. I put that in front of it, completely worked. I don't understand why. I'm not going to sit here and act like I'm a professional expert or anything like that. But it works. So now when you press in when a public key, like in the command line or via parameters file, it works. So just keep that in mind if you're ever deploying a VM and have some sort of issue with providing your key. Give that a try. So anyway, if we scroll, I think the next one is VM2. Essentially same thing. The difference here is this one doesn't have a public IP. But same type, same size, all that kinds of thing. Awesome. What do we got to the okay, cool. So with Bicep, you can also output values if you need to. So in our case, we're just going to output the DNS settings or the DNS, like the label or that we had for our VM. And here you can set this to output anything. There's also this decorator that's, I think it's @secret. And if you add the @secret decorator to a parameter, it won't ever output anything to the command line or as an output. Typically, you'll use that for like password or something like that. That sensitive data that you don't need to. All right, so I'm trying to figure out how we can deploy this, Liam, because are you signed into
I have got none of this set up on my machine. I was definitely not banking on this failing today. I got a solution. What we will do is in the next stream, what I'll do is I'll make sure that we deploy all of this in one fellow swoop, because that will kind of go hand in hand with what the next stream is all about, I think. Rather than trying to fuzz that up in 7 minutes and get it all rushed through, I want people to understand this properly. So I think next week, what we're going to do is we will run whistle stop through this again so you all understand. And then we're just going to spend maybe like the whole hour on code as opposed to like a presentation. Does that sound good, Gwen?
Yeah. Sorry, I was going to say maybe I try to share and then just mute my mic. And when it's done, I'll remove my screen share. But that might be too fuzzy. So yeah, we'll deploy in the next one. But essentially at this point, you can just do, what's the command? I think it's like AZ deployment group create. You create a deployment group and then you use your Bicep file and it'll send it off to your Azure subscription, wherever you have it, whichever resource group you're using. But we'll have this set up for the next one. Apologies, no idea why I'm getting audio issues here. It's never happened before.
You haven't had this before. This hasn't happened before for StreamYard, so it's always a first time for everything, and I can only apologize to everybody for this not working properly. But it'll work out better next time, we promise. Because yeah, we'll be able to do this in one fellow swoop, and it'll probably make a little bit more sense in one fellow swoop, to be fair. But we can just kind of pause it here. What I will do is I'm going to bring up the slides one more time, because we have got some interesting things for you to do. So we can pretend that we have deployed our network. We can pretend it looks like this. And the recap. So we've kind of looked at what virtual networks are, the nuances involved. We've looked at what infrastructure as code is and how and why it's used in teams and kind of the benefits of that. And we're going to pretend that we did build and deploy the network. So it's been built. We just haven't managed to deploy it, unfortunately. But that will happen next episode. Hold us to it. So the fun thing for you to do is we're not going to wait till the end of this series to throw out a Microsoft Cloud Skills Challenge. We're actually going to put it out today. And we're going to let you know the link in just one moment. But essentially, a Cloud Skills Challenge is an entire bank of wonderful Learn modules, all associated with this series this month. And looks a little bit like this. And you can see there's a time association with it. There's more than just these 4 on there, but it's starting off with Azure Virtual Networks, going into Bicep templating, building in reusable and parameters, and looking at modules in Bicep, because that's a really powerful part to understand the language. And then it just sort of tails into some other really cool, fantastic services that Azure provides. If you complete all of the modules that we have put out, we are going to give you a 50% off voucher, which you can throw towards a certification. And we'd love you to put it towards AZ700. So that's all about becoming a network engineer associate. So it's a really cool certification. I'm working towards it at the moment myself. And the link that you can use to get this or get to the challenge is aka.ms/Azure VNet CSC2. Feel free to take a screen cap of that one, or sort of take a picture of it on your phone or something. And it's going to be awesome to get this, because having these kind of certifications don't just bode well for you professionally, but it also helps you understand what we talk about a little bit more in these streams. And, as developers, we want you to all learn and upskill and be the best you can with this. So it's great that you're here, and we want to sort of reward you with this if you can go ahead and complete our Cloud Skills Challenge. If you want to do that and you do complete them, how do you redeem the voucher? Well, because we cannot capture any of your personal data, not that I want to anyway, you can reach out to us on Twitter or LinkedIn. You don't have to connect with us. You can just reach out, send us a message, and just send us a little screen cap saying, hey, I've completed it with the modules, and just to show that you have done it. And we will get that voucher sent over to you as soon as possible. So again, that is the link. So aka.ms/Azure VNet CSC2. It's a bit of a mouthful. But please do take a screen cap or picture, and you can get on with our Cloud Skills Challenge. And with that, we'd like to say thank you very much. Wholesomely apologize for the demo not being able to work, but it's okay. We will get there. If you have any questions, please do reach out to us on social media. And of course, Gwen, we forgot to put your YouTube channel on here. Shout out for your YouTube channel because you run it. What's your...
Yeah, it's youtube.com/made by GPS. Some of you might be watching there at the moment. Liam, I just wanted to let you know that I know we said 50%, but it's actually 100% off.
Oh my goodness.
So surprise everyone.
Amazing.
If you complete these modules, this expires May 27th, I believe. So you have over a month to sort of pace yourself, watch our live streams. We're going to be covering a lot of the content as well. Get the modules. Make sure you're signed into your Learn account, because we'll have a leaderboard and we'll be able to sort of, push each other, hold each other accountable, check each other's progress. And then, I think we have a good amount of vouchers to give away. But yeah, 100% completely free. Towards any certification, but ideally we want you to do something like networking related, so the AZ700. I'm personally also studying for that as well. So it's like a little study group that we got going on. But yes, 100% off. We worked hard to get these for y'all. We worked very hard to get all these for y'all. So I'm very excited to see everyone learn some new stuff, and we'll all get certified together.
Gwen is coming through with that one for you all. Absolutely fantastic. So yes, thank you ever so much. And we will be taking questions now. So if you want to throw some questions up on the screen, we can spend a minute to answer them if we have time.
Hello. So I start a couple of them for you to see. Just for the audience out there, we are streaming to multiple channels. So not just where you're tuning in from, but a few others. So if you see us answering questions or responding to questions that you don't see in your chat, that's because it's on another chat. So while you guys look through the questions, see if there's any ones that you want to call out. Again, you'll see them in the Start tab. I will just quickly do a Reactor plug. So if you're tuning in and you have not heard of the Microsoft Reactor, it is a program that Microsoft has put together for community. We put out free content on a weekly basis. We were physical spaces. We've moved to virtual. We plan to have hybrid sessions coming up in the near future for in-person if you happen to live in a vicinity of one of our Microsoft Reactor locations. And we will be putting all of that out on our calendars as well. You can find us on Meetup. So go to Meetup, search for Microsoft Reactor, find the location that works best for you. If you happen to not be directly adjacent to it, but it works for your time zone, sign up, check it out, see what we list, whether it's an in-person in a physical space or a virtual or hybrid online event. So you can tune in for those ones. That's me. Was there any questions that we missed through the session that you guys wanted to shout out?
I think.
Yeah. Is there a couple in the chat that we can throw up on the screen? Because this chat is on fire. I am reading through it, looking for the starred ones. Okay, so let's just start from the top. We got a couple. If the database is in a private subnet, can a developer write a C# program to upload data? Yes, you can. And the way that you do that is that C# program would typically be running on a virtual machine or in a service which is running in a public subnet, which you would then have connected to the database. So a database is always going to be in a private subnet because you don't want that data being visible to the public, right? If there's an IP address associated with that database inside the network, you don't want someone to be able to type in, 192.168.1.1 or whatever and be able to get the data. Okay, that needs to be hidden from everything. So yes, you can update it. That is how it works. So good question. Okay, so the next question is, would you recommend static routes in your topology or using dynamic routing protocols like OSPF? Oh, this is taking me back to my networking degree. Oh, I love this one. You would typically use dynamic routing protocols. The reason you do that is because you wouldn't want to statically address anything with a static IP address unless you know it's always going to be that IP address. So you always want to keep them fluid, keep them updating, and yes, using protocols like OSPF. I cannot for the life of me remember what that actually stands for, but yes, you would use that. That again goes with like the BGP acronyms. This is all quite like a deep level in networking, but awesome question, and I love it. Okay, what's up next?
We got this one here.
Okay, then what's this? Can the C# run on the developer's desktop machine to upload data to a database in a private network? If so, will we be discussing this? Kind of already very quickly covered that.
Yeah.
That was kind of through my presentation, and that was like a simple direct connect to the virtual network in Azure. Again, you use like a VPN tunnel with that as well. Let me just go grab that one up. What was it? It was called point to site VPN, and that is what you would use for that one. There's like a single computer to a network, but you wouldn't do it directly to something in a private subnet, if that's what you mean. It says private network, but I can assume that's like a virtual network in the cloud. Okay. So we have got, depending on where the C# app is running, you can all the app to upload to SQL.
I think that was an answer to one of the previous questions.
Yeah, I think so. Yeah, it looks like it. Okay, cool.
We got this one here. Oh,
okay.
Yeah, there we go.
Is it Bicep versus Terraform, etc., or can you use both, or it depends on the use case situation? I love these kind of questions because it's typically down to preference, right? I don't know about you, Gwen, but I don't know all the languages. They're all pretty similar. They're all pretty familiar. They don't go too wrong, right? With a decorative language, it's kind of A equals B, like we kind of went through. It's just the syntax and the APIs and variables out there. One issue I had with Terraform was in one of my streams, it didn't support one of the functionalities that I was looking for in Azure on app services. And it was to do with CI/CD. And it was like a hanging pull request, which if they had just clicked merge, it would have like made the demo crisp, but it doesn't. And that's the kind of risk that you take. So it's not Bicep versus Terraform. It's which one suits your needs.
Perfect. We got this one here.
Cool. Hello. So in networking, we call it a VLAN. Yes, that is correct. Is this the equivalent to a VNet? On top level, yes. So a VLAN is obviously like a subset of computers under, or subset of hosts underneath a specific IP range, whereas a sort of a VNet is more of the virtual network itself, split down into subnets. And again, you can play subnets off with VLANs and how they're attributed sort of across the network in a network topology. So not quite the same, a little bit different. VNet is like a virtual network from Azure. VLAN is like a networking terminology that you'd use to describe that. Okay, what's the difference between internal and private when setting up a VNet? Okay, so I'm only assume you mean internal hosts, maybe? What's the difference between internal and private when setting up a VNet? So let me just think before I speak here, because I'm trying to interpret that question and try to figure out what you mean.
Might need a little more context. Mark, if you're there, is this related to something that was in our Bicep file, or is this just a networking question in general? But if you could provide a little more context, that'd be great. We can move on to this other one until...
Yeah, jump in. This one. Question regarding Bicep. Maybe not for today, but in another session, how do you wait for resource allocation to finish before continuing to the rest of the deployment? Perfect question. It's automatically done in Bicep. It is run through. So when you click Bicep build, it essentially takes the Bicep language and compiles what you've written down into an ARM template. Essentially what it is, right? It's a JSON file. That JSON file is what gets deployed. And you have like a little spinning thing in the terminal. And we will show you this next session, don't worry, when we actually deploy this. You'll see it happen. It's automatically done. You don't need to worry about that one.
I think there is a decorator where you can assign some sort of priority, but this is usually not what you need to do. I'll see if I can find it.
Yeah, if you can do that, that'd be awesome.
Worked with it. Let's see. And then here's this one here.
Okay, what causes the subnet to get deployed after the VNet? How does the dependency work? So this is the magic, and I say magic, of the cloud provider, right? So the cloud provider consumes this template that you're sending into it. And obviously, if the virtual network is not there prior to creating a subnet, well, then it's going to figure that out, that it's going to have to assume that you have a VNet or virtual network declaration coming for it to create a subnet. And if it's not there, then I'm sure it would throw back an error. But that's a good question, because this is all to do with decorative programming, right? You can essentially describe your end goal in one file, and the cloud provider then figures it out on their side as to how that is deployed. And if there's any problems in that, then it will come back to you and tell you there's a problem.
Awesome. I think that's all the questions. I'm trying to see if I can find that. If not, I'll have to add it to the next. Because I know when you have the concept of like chaining modules and stuff like that, you might need what is it called? I know there's something. It's on like the tip of my tongue. I literally just read about it. But anyway, I guess we'll have it for the next one. But there here we go. There's a depend on flag you can set in ARM. I'm assuming that yes, it's
nice one.
Let's see. Let me see if I can quickly just depends on. All right, probably not. But there's a decorator that you can use. I'll have it ready for the next one. I think we got all the questions. We didn't have Mark to provide us more context about his question about internal and private when setting up a VNet. So hopefully you'll be here on the next session. We can talk about that there. But that's it for this one. Apologies for my voice, coughing, and my computer. We're both sick. But we'll have it all sorted out for the next one.
We sure will. Thank you ever so much, everybody, for joining.
Thank you, everyone. Take care.